Welcome to students and viewers. Here again we will discuss a few sums on proportionality theorem. Now in question number 1 it says DE is parallel to OQ. DE, this side is parallel to OQ, and DF is parallel to OR. This DF, this line is parallel to OR. We have to prove that EF parallel to QR. Now if you have to prove EF parallel to QR, let's see in separately. EF parallel to QR. So that means you will have to show that PE by EQ equal to PF by FR. That means EF divides the other two sides in the same ratio. Then only you can say EF parallel to QR. So from the given condition you can see, let us prove this. In triangle A, not A, PQO. PQO, this triangle PQO, you find that DE parallel to OQ, right? This triangle you see, DE, it is parallel to OQ. In PQO, this triangle, DE is parallel to OQ. Therefore, by proportionality theorem, you can write here PE by EQ equal to PD by DO, right? Let's say this is 1. This is by proportionality theorem. Now think about other triangle. This time DF parallel to OR. So you consider triangle POR. In triangle POR, you find that DF is parallel to OR. So here you can say PF by FR equal to PD by DO. This is supposed to. So in both cases we are using proportionality theorem, right? So you can mention here in bracket by proportionality theorem. What is proportionality theorem? A line which is parallel to one side of a triangle divides the other two sides in the same ratio. So DF is parallel to OR, that means this divided by this equal to this divided by this, right? Now from 1 and 2 you see right hand sides are same. 1 and 2, you can conclude that PE by EQ equal to PF by FR. Since right hand sides are equal, here right hand sides are same, so left hand sides must be equal. Therefore, in triangle PQR, PE by EQ equal to PF by FR. You treat this ratio in triangle PQR. Consider this ratio in triangle PQR. Let us come to triangle PQR. You find that PE by EQ equal to PF by FR. Therefore, EF parallel to QR. So here you are using the converse of midpoint proportionality theorem. What is the converse of proportionality theorem? It says if a line divides two sides of a triangle in the same ratio, then it is parallel to the third side. Now EF divides PQ and PR in the same ratio, this divided by this equal to PF by FR. Therefore EF is parallel to QR, right? So this has to be proved. Now let us come to question number 2 here. ABC are points on PQ, not PQ, OP, OQ and OR respectively. That means A is on the point on the line OP, B is on the line OQ, and C is on the line OR. And it is also given that AB parallel to PQ. AB is parallel to PQ. And you are given that AC is parallel to PR. This is parallel to PR. Then you have to prove that BC parallel to QR. So let us find it out separately. You have to prove that BC parallel to QR. That means you consider this triangle OQR. If you have to prove BC parallel to QR, then you have to first show that OB by BQ equal to OC by CR. Then only you can say that BC is parallel to QR. Right? So let us prove this. First come to this triangle. You are given AB parallel to PQ. So you treat this triangle OQP or OPQ. In triangle OPQ, AB parallel to PQ, right? Therefore, by proportionality theorem, you can write OA by AP equal to OB by BQ. This is suppose 1. Now let us come to this triangle OPR. In triangle OPR, here you are given that AC parallel to PR, right? This triangle is like this, OPR, AC parallel to PR. Therefore, you can write OA by AP equal to OC by CR. This is suppose 2. Now from 1 and 2 you can see left hand sides are same. So you can compare the right hand sides. So from 1 and 2 you can conclude that OB by BQ equal to OC by CR. Therefore, in triangle OQR, you see in triangle OQR, you find that OB by BQ, OB by BQ, OB by BQ equal to OC by CR. That means this line BC divides OQ and OR in the same ratio. That is BC divides OQ and OR in the same ratio. Right? Therefore, BC is parallel to QR. If a line divides two sides of a triangle in the same ratio, it is parallel to the third side. So BC divides OQ and OR in the same ratio. OB by BQ equal to OC by CR. That is BC is parallel to QR. Let's come to question number 3 here. Prove that line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. So let us consider one triangle here. Say this is triangle ABC. Line drawn through the midpoint of one side. Say this is the midpoint D of AB. Parallel to another side. Let us draw a line parallel to BC from D. And say this line intersects AC at E. Now we have to prove that DE bisects third side AC. That means AE equal to EC, right? So given that AD equal to BD, that means D is the midpoint. DE, it is parallel to AC, BC. DE is parallel to BC, right? Now prove that, to prove that AE equal to EC. That means E is the middle point of AC. So let us prove this. Now by proportionality theorem we find that a line which is parallel to one side of a triangle divides the other two sides in the same ratio. By proportionality theorem, a line parallel to one side of a triangle divides the other two sides in the same ratio, right? Therefore DE is parallel to BC, right? By construction DE is parallel to BC. Therefore AD by BD equal to AE by EC. This is by proportionality theorem. Now you are given that AD by BD equal to 1, since AD equal to BD given, right? AD equal to BD, therefore AD by BD equal to 1. Therefore AE by EC equal to 1, or AE equal to EC. So AE equal to EC means DE bisects AC. That means this line drawn from the midpoint of AB parallel to BC bisects the third side AC. So this has to be proved. So thank you viewers for watching this video. A few sums of this exercise are yet to be proved. So we'll discuss those sums in the next video again. Keep in touch.